This video is intended for entertainment and historical purposes only. It's not meant to be an instructional tutorial or provide professional advice. Over the past episodes, engine number 1 has gone from being a mostly complete locomotive to being torn down to its most basic components. This two-part video marks a turning point in the restoration as we transition into the reassembly stage. Today, we're going to be getting engine number 1 ready to go back on its wheels. This means addressing the last of the dynamite damage, mounting the cylinders on the frame, and then sorting out the bent side rods. By the end of part 2, which will be out next Friday, engine number 1 will be a rolling chassis and actually resemble a locomotive once again. For those of you who can't wait until Friday, the complete video is already on Patreon and the YouTube memberships page. If you're new here, hit that subscribe button so you don't miss out. Remember, it doesn't cost you anything, but it sure helps grow the channel. We've got a lot to do today, so let's head into the shop and get to work.
Well, it's now time to start working on building the locomotive, putting it together. There's an old saying that you can't build a good house on a poor foundation, and this also applies to steam locomotives. And so, to this end, I've got the frame all sandblasted, it's all cleaned up, it's been inspected for cracks, and it's in reasonably good condition. However, I got some repairs to make. And the frame is on the car hoist because I'm getting old and working on the ground just doesn't work for me anymore. The frame is upside down at the moment, and the reason is that I have to work on the binders. Now the binders are a bar that's notched, and it goes from here to here, holding the frame together. The wheel sets are through here, but they have to be removable, so this is a removable piece. It's really hard to get at unless you have a pit once the locomotive's on the ground, so I want to make a good job. This has been drilled out for some reason, so I've got to drill it 7/8, 3/4 stud, drill a broken out stud here, and put a new stud in. And just generally twig things up so that they're easy to work on later on, because they're upside down and they're really kind of hard to get to. This frame has a problem. When they disassembled the engine and took the boiler off of the cylinder, they used explosives. That's a miner's way of doing things, and they can be handy. But for every action, there's an equal and opposite reaction. So when they blew the boiler up off the frame off the cylinders were driven downwards with the same force, and they bent the frame. So you can see that the frame is straight, and then here it's bent. It's bent downwards, but right now it's going upwards because it's upside down. So it's bent probably here. We have to heat it up and realign it and straighten it. Now, bear in mind, these are steel. These are cast steel frames. They're standard North American practice. And so they're repairable. They used to break. They used to be welded. You would get cracks in here that you'd have to gouge out and weld. I personally replaced this section in here because it was broken and the welding wasn't very good, and so we just made up a whole new piece and welded it in. Steel is difficult to cast. It's sticky. It doesn't want to flow. And to this end, for example, you can see here all the porosity. It's not a great casting, but it's definitely been strong enough. It's held up all these years. As well, on the back end, there's some damage. It's important to remember that the way these engines, all steam locomotives, were made was that the cylinders at the front were bolted rigidly to the frame, and the boiler was bolted rigidly to the cylinders. But the boiler expands and contracts as it's steamed up and gone cold, so it has to be able to move at the back end. And to that end, there are sliders on the side of the boiler. But the boiler is still part of the frame. It helps us with rigidity. In this case, after they took the boiler off and turned it into a gas-powered locomotive, and then they were finished with it, they shoved it in the ditch with a cat, they bent this frame because it's unsupported, it has no help. So I have to put a jack in here and push this out 3/4 of an inch by heating that corner. Now you notice how these frames jog out. They were originally straight when they were cast and machined that way, and then were jogged out by heating them red hot and moving them out to fit the boiler. I've got to tap this. This has been drilled out, and I have to put a 7/8 by 3/4 inch stud. So this is one cleaned up frame member. You can actually see the machining marks here where they machined the two as a pair. They're matched by marks over here. You can see the casting flaws. So we're going to fit the binder. I've cleaned up the threads so that they're nice and sharp and in good condition, because these are very important. You'll hear people referring to tightening up the binders. On any locomotive, they tend to work themselves loose and have to be constantly checked with a big wrench and they're really hard to get at. Don't forget all the valve gears in here. Spokes of the wheel are here. Hard to reach. This is the binder in the process of going on. You can see how it fits and holds the frame together, both sides. I like to use hardened washers. Then the nut doesn't dig into, these are double extra heavy nuts. You need the biggest nut you can get. So this is an H2 nut. These are hardened washers. They don't allow the nut to dig into the material. They allow you to get it good and tight. Now, conversely, standard nuts are quite a bit different. This is the standard 3/4 inch nut, but there's not much to it. I call these hardware store nuts. So we'll bolt this down. As it comes down, it tightens in here. It's good to apply a little bit of oil on each side here because you want it not to bind. You want it to be able to move. I use Never Cease in these two surfaces, and that allows it to slip and not gall. This hole is for the adjustment of a wedge. If you look at the back, these are called pedestals. And there's a liner that goes in here that the bearing rides up and down in and wears on, and they're replaceable. And the other one is tapered. And so the whole idea is to get the play out of here. You have a bolt that goes in here, that goes down and moves the wedge up and down. As I've said before, binder bolts are really important. You can see those two over there and how the binder doesn't actually come down tight. It only fits in the wedge. In this case, there was a bolt had been fitted, and I drove it out because it's not supposed to be a bolt, it's supposed to be a stud, but obviously the stud broke off. Somebody drilled the hole out to 3/4 inch, and so I've knocked this out, and I wasn't wrong in doing so. When I hammered it out, the cracks on the end of this piece of material, this is just a piece of cheese that somebody had in their box to fix this locomotive at the time. So we're doing a little better job here. To that end, I've tapped this out with 7/8. You can see down the hole. It's nice clean steel. And this is a stepped stud. This started out life as a grade 5 7/8 bolt. This is the original thread. I cut some off the end, turned this down to 3/4 and threaded this to 3/4, and it screws in and it goes right down to the bottom. I use a little bit of Loctite in here to keep it from coming loose on me. And there you have it. This is the end result. This has been sucked down. Not too tight because I got to take it off again. It's important that they always have a space under here and under here. If they're down flat on the frame, they're not tight anymore. The same in this end. There's a space here and a space here. The next thing I have to do now is to go around all the binders and cut the tops off the threads. If you look across there, you'll see the threads are even with the top of the nuts. There's a reason for this, is that these are exposed in harm's way under the engine, and if they get clipped on a rail or a rock, it brunels this all up and you can't get the nut off. So I'm going to use a zip wheel and cut these off. Correctly fitted binders, you should be able to see right through, and it's only fitting on this surface and this surface. They're not to touch on the top, and they're not to touch the frame. If they do, then you have to build these surfaces up with weld and carefully refit them so that they're proud again. So this frame side has been straightened. It went really easily, actually. Just heated in the corner with the rosebud till it was red hot, and stood back here at the back corner and just smashed my hip against it, and it went over really easy. So now it's straight. These two rails are parallel with each other. Will fit in the boiler, and now it's a matter of painting the frame before oil and whatnot gets picked up in it. So we heated up the frames where they had bent just back of the cylinders. Remember, this is upside down. We used 2 big rosebuds, one on each side, to get it hot as quickly as possible in a very small area. We didn't want too much heat affected zone, and we beat them down with this big dead blow hammer and on that spud there, and it looks like we've got them pretty close. Hard to tell. I think they're okay. We're now just going to paint this up and then start fitting it to the cylinders, and we'll find out very quickly if the cylinder saddle sits squarely on these points. But I think we're pretty good. Well, we got the cylinders fitted back onto the frames. Everything seems to be reasonably straightforward. Started the wedges. There's wedges in the front that actually hold the frame tight, and they're quite tight. They're on each side, but not all the way down yet. I now have to make bolts to go through. These holes have been were originally 7/8. They've been drilled out, reamed out to 15/16, and there's no such thing as a 15/16 bolt. So I'm going to be making some stepped bolts that are 7/8 threaded on both ends, 15/16 where they go through the frame. We've got the frame laying pretty much level. There's no space under here, under these edges here. The other end is supported by a screw jack, so we can play around with it a bit. But it's actually turned out pretty good. Everything's reasonably straight as it's going to be anyway. So now I've got to make the bolts and bolt these cylinders down rigidly to the frame. So I'm making the bolts up to hold down the seam steam cylinders. This is just 1-inch A36. I've machined these ends down to 7/8 and they'll get threaded. I've laid out a drawing so I know what size to do things with. So now I'm going to go to the power threader and thread these. These do not need to be threaded in the lathe. The power threader will do just fine because it's just a nut going on each end. This is a rigid 535 power threader. Very handy machine. Its primary purpose is for threading pipe and bolts, and I use it a lot. The material is mounted in the chuck. The chuck is a hammer chuck. You can loosen the material or tighten the material. There are little tiny jaws in here that really dig into the material. That's why I haven't turned this yet. I'll do it afterwards. So it's simply a matter of turning the machine on, offering it into the material. This die is a 7/8 die. It's set up a little undersized. I don't want the nuts too tight. And so we just fire it up and thread the bolts. It's pretty noisy. And there you have it. Try the nut on. See that it fits properly. There you go. This is the bolt assembly that we're making up, 4 of them, to bolt the cylinders down. The cylinders themselves, the actual casting it's a little thinner than this, and it's cracked and not the best. So I've made up doublers that go inside. This goes inside the cylinder. The frame is actually 3 inches thick from here to here. So, the frame and the casting. So this is the way it will go together. The nut will just screw onto the bottom and tighten this in just a little bit. Just want it hand tight. And then you can screw this down and cinch it down, and this part of the thread doesn't show proud. It stays inside the frame, which is quite thick. So a little bit in here doesn't matter. And now I have to machine each one to a diameter fit. I mentioned before that you machine them after you thread them because this is the kind of marks that you get from the 535 dies. They really dig in, they don't slip, but they chew up the material pretty good. So if you're on a pipe or a bolt, you don't really care, but these are fitted bolts. So now I've measured all the holes. I've got to put this back in the lathe and turn these down to specific diameters. If you remember the discussions about planning ahead, this is another example of it. This is the bolt that we have to turn the outside diameter on. When I started out, I put a center in one end, and so I can hold it in the chuck. So as you can see, I can hold it on its diameter and still machine it and support the other end here in a center. And it allows me to make a fairly accurate machine job. So I've left a little bit so I can get the tool past it. It's in the center. Now all I have to do is tighten it and machine it to the diameter. I'm going to machine the first bolt first, which is 0.950 in diameter. It's the biggest one, so if I screw up, I can always turn it down a bit more to fit the other hole. It's just the way life is these days. This is 955, so I just got to take a little bit more off, and the first bolt is done. Here are the bolts in frame. You can see that when I've driven all the way down, so you can see there isn't a lot of room to put a nut on over the other side there. So there's enough, just enough. It's important to clearly understand that the purpose of these bolts is not to locate the frame. These aren't like center pins or anything like that, tapered pins. These are bolts, but they're usually fitted fairly nicely. The cylinder is retained in the frame by being recessed in here, and it has an edge that it bumps up to here to take the thrust. It's recessed into the frame, and the front has a wedge that's driven in to make it tight between the cylinder and the frame. This is where the thrust is taken, here and here on each side, not here. Some steam bigger locomotives have many more bolts holding the cylinders down, but it's not the function of the bolts to locate the cylinder. It's merely to clamp it down absolutely tight on the frame. You can see on the other side there where I haven't driven the wedge all the way in yet, because once it's in, it's hard to get out, and I wanted to make sure that everything is good. But this cylinder, when the frames were machined and the cylinder was machined, it was designed to be keyed into the frame itself so it can't move. Well, here we are after much fiddling around. We finally got the doublers in here. They had to be fitted a little bit. These bolts are tightened down tight. They're not going to move anywhere. The wedges are in over there and here. And everything's tight. So we're kind of done with this end. Cylinders are reattached and ready for service. Now starting on the side rods, taking them apart, inspecting them and fixing them. You can see that this side rod has been pushed with a cat, and it has managed to bend things pretty badly. It's even bent the strap, which is bent right here. It's gone that way. This strap, which is the front one, is actually marked with a 7 and an 8. And further to our previous discussions of making connecting rods, the bolts only fit in certain holes. And this is from the factory, and it's the same thing. These bolts hit together. If you mix them up, one goes way down and one won't go in at all. So you have to be able to mark or make sure the parts are marked. Now in this case, there is no marking on these bolts. There's a shadow of a couple of letters that don't really make a lot of sense. So I'm going to restamp these with the numbers that are here so I can get them back together. The brasses are also matched. LFH, I'm not sure what the H is, but the LF is off left front, obviously. And this strap is almost impossible to see, but there is an LFH here, and it will no doubt be on the side here. So as you take these apart, make sure you mark all the pieces, the wedges, all the bits and pieces. Using paint is nice because there's no guarantee that somebody else put this correctly together. And if you stamp it, then you have to restamp it. So I mark it with paint. And as I take things apart and clean them up, I figure out who goes where and who belongs to anybody. Here we are with the back end of the left side rod. You can see it's marked LBH, B being back. I don't know what the H means. And it's marked here. You can barely see it. Somebody else in the past has put 2 punch marks on here because they were aware of how important it is to get the parts mixed out. The bolts have 2 punch marks on them when the person put them back together or took them apart. And they are marked on the top of the strap as before. There is a 5 and a 6, hard to see. These were probably stamped, but I can't read them. So, again, this is what we're up to. The rod is also marked. So it's pretty hard to get it wrong once you figure it all out. This assembly is going in the hot tank to get cleaned up. And so it's been reassembled with all its component bits in all socket. And the bolts have been written with paint. They're not going in the hot tank. The rest of it is. And we'll just get this all cleaned up and see what we can do. But again, it's important to pay attention to what's going on. And remember, there's no guarantee that it was right before. You can also see where somebody hit it here. And the key has been sheared right off. I have to make a new one. I run into a very typical problem, and that is the grease hole. Somebody in the past has over-tapped this, and now it doesn't work because, of course, any fitting you want to put in there goes all the way to the bottom and is still loose. You don't want to weld this. This is the weakest point of this entire strap. across this hole. This hole is actually bigger, as you can see, than the key. And so you can't weld it up and then drill it down. You don't know what this material is. You put stresses in it. So the way it's done is that you make an oversized nipple, in this case like this. And this is a die head off of a rigid 535 threader. And as you can see, you can move these dies in and out and change the size. And so what I do is I put a nipple like this in. I over thread it. In other words, I make it a little longer and bigger so that it fits into this hole very tightly. And then I cut it off and I drill and tap it with 1/8 NPT. And that way you don't have any problems. So this is the die head fitted in the machine. These dies are 1/4 and 3/8. I think you can see that. And I've set them up oversized. On the top here, it tells you the various sizes. There's a 3/8 NPT, there's 1/4. I'm a little over 1/4. I've got it locked down with this. And I'm going to attempt to thread this nipple in this die and see where I am. So it's just simply a matter of starting the machine. It's quite noisy, and running a thread. These are bloody good machines. They're not used much anymore. Different piping methods now, but you can see I've threaded an oversized thread on here, and we'll just try it out and see if it fits. So this is the oversized thread. You can see that the top end, it's barely making threads. I'm going to screw this into here with some bearing locker. It goes in, but it does tighten down. There you go. And then we cut this off, drill it, and tap it for 1/8 NPT. And you haven't modified the strap, but you've repaired the hole. So this is the affected repair. It's a 1/4 inch nipple, schedule 80, screwed in with bearing locker, and drilled out and tapped 1/8 NPT. It doesn't go through on the inside. And I've left it a little proud so that the next guy can see that it's actually there. If you grind it off flush, well, it doesn't spoil the look of anything, but it does tell somebody that there's been a bushing put in. Here we are ready to put the first strap together. It's been repaired. You can see that this doesn't go inside. It's countersunk so the grease can find its way out. Side rods are bushed and shimmed both ways so that they fit properly, and these brasses aren't very good. They're new, but they're not that big. So I've kept track of, this is one left, it says back. So these go in here. We'll figure this all out when we actually go put the engine together. This is so you can get things adjusted. These are fairly crudely done. They're new, but they've been, well, they're pretty crude. But we're not going to change them. So this basically drops in. The other brass drops in. Get it the right way around. This one's just a tad tighter than the other one. It's not enough to be bothersome, but it's still there. Another stack of shims. These are all left, one left, and a W stands for wedge. You can see where the wedge goes in here. And these have been messed around with, and I'm not really sure where all this is, so I'm just putting it together. I'll worry about it when I go and put the whole engine back together. So we just offer this into here. And the bearing sits in a groove. The tapered bolts, which have now been marked for their holes. There's a 7 and an 8. And this is a 7, so it goes here. And number 8. Tap them down. And the wedge, wherever I put it. For some reason, this is a pretty skinny wedge. But it does, you can look down the hole, you can see the shims in there. And this goes and pushes against the shims and keeps the bearing tight. And there's a set screw here to tighten it up. So this is fitted. Nothing's loose. These always are fitted cheek to cheek. In other words, there's no gap here. When you put the grease in, it goes into the bearing and keeps the bearing lubricated. If there's a gap in here, you can have problems with people driving this wedge down too far. But this is just roughly fitted and back together, which is all I'm really after right now. And I'll do the other 3 ends on the other rod, and the end of this rod and the other rod, and we'll go from there. So I'm working on the last end of the side rod. And this particular end was badly bent. It's been straightened. The whole rod's been straightened. And by the way, side rods get bent and re-straightened quite a bit. They're in harm's way. They're going up and down, especially on a construction engine where they're very close to the ground. They hang up on a rock or a stump, and they're constantly being straightened out. So it's straight. However, this piece is solid. It bent there, and it bent across the weakest point here on the strap, and I had to straighten this strap out. And in going to put it together, I discovered that this hole has been stretched so that it no longer fits properly. It's loose. So to that end, I made up a new bolt, which is slightly bigger. And fitted it. Always check the wedges when you have the engine apart to make sure that they're correct. This wedge is marked for this particular end, and it was used in this end, but it doesn't fit. As you can see, it's not square. It's been machined at the wrong angle, and that's easy to do, and I've found these slots vary. That's why the wedges are actually marked for each end, is because they're fitted to each end. So what's going to happen here is that when this wedge is advanced, it's going to push on the bottom part of the brass, not the top, and cock the brass or make it go crooked or deform the brass, and it's just not a great idea. So to that end, I've made up a new wedge which fits. You see it's parallel, right? And as it advances, it comes out and pushes on the brass squarely and evenly. In addition, both of these rods were put together with hardware store nuts. You can see they're just stamped out. They're flat on one side. There's no recess, but they're crowned on this side. And the whole reason for double nutting is to make things tight. If this side is crowned and you stack them together, they're not going to be tight. They don't fit properly. Some of these bolts were not threaded far enough. You can see where I have rethreaded this a little bit farther. They stopped the threading before the end. And some places the bolts went through too far, and instead of rethreading the bolt, they drilled out the nut, which is not the best way of doing things. So these are the new nuts. They're double-sided. They're full nuts. There's one stacks on top of the other to lock together so things can't come loose. And we'll put this all together and call it a day for the rods. This is the gaggle of rods we've got for this engine. They're all finished. They're all ready to go on. And they've been straightened and new parts made and one new rod and all sorts of business. But it's all ready for service. They all just have to be fitted as we assemble the engine. It's a lot of work fiddling around with this, especially when you got to make a lot of parts. But at the end of the day, it's rewarding because they're going to give good service.
Thanks for watching right to the end of the video. If you're enjoying the project so far, go ahead and hit that like button and leave me a comment. And if this is your first time here, check out these other videos from the series. I think you'll really enjoy them. Before I go, I just want to give a big thank you to everyone who's signed up to the Wrecked or Restored Patreon or YouTube memberships page. Your support is greatly appreciated.